going to continue our study of the measures of central tendency by looking at this activity titled, "What did the boy bumper car say to the girl bumper car?" Now, if you are able to get each of the correct answers, then you will be able to break the code at the bottom of the sheet. And in doing so, you could earn an extra point on the activity, so that if you do miss one of the other problems or mistype one of the other questions, you'd still end up with 100% on the activity. Let's look at the first question. The table shows the lengths of 8 canoes. The mean length of the canoes we can find by adding up all of the x's, so in this case all of the canoe lengths, 13 plus 15 plus 15 plus 16 plus 3 times 17 plus 18, and divide by the total number of canoes, which were given as 8. And that'll give us the mean, the x bar. The median is going to be the canoe length that's immediately in the middle if we put the canoes' lengths all in order. When we do that, you can see that I've done that here in the top right. When I do that, I see that the middle is going to be between the 16 and 17 because there are 8 pieces of data. That's even, so there's not a precise piece of data in the middle. So we take the middle point between 16 and 17. So it looks like the median is going to be 16 and 5/10. The mode is going to be the canoe length that appears the most often. You can find that by looking at the list here in the right, or by using the number from the chart, whichever is easier for you. And then that leaves us the range. I want to also talk for just a minute about the mid-range and remind you of what the range and mid-range both represent. The range is the distance between the high and low values. The range is the distance between, in this case, between 13 and 18. Whenever you're trying to find the distance between two things, you simply subtract them, and that's going to give us the range. But I wanted to show you why that's the range, because if we look here at the bottom left, this 13 to 18, if I put the 13, 14, 15, 16, 17, 18 on a number line, what I'm looking for is how much space there is between them. And it looks like there's 1, 2, 3, 4, 5 units between the 13 and the 18. So that's our range. How far of a distance is there between the high and the low values? The mid-range is that value that's immediately in the middle of that range. So if we looked again from at the 13 to 18, let me erase some of the extra markings. We could see that the middle of the range, the middle of that space between the 13 to the 18 is going to be the 15.5. But you could also use this formula, add the high and the low. Addition is commutative, so it doesn't matter which one we put first. And then divide by 2, and that's going to give us the mid-range. Moving on to the second data set, we've got bats and their lengths. This one's a little bit different. We have to apply what we remember from frequency distributions as well. The total number of bats. We've got 1 bat that was 31 inches long, 4 that are 32 inches long, 3 that are 33 inches long, and 5 that were 34 inches long. So if I want the total number of bats, I would have to add the 1 plus 4 plus 3 to 15. Now this total combined length of all the bats, make sure you understand what that question is asking. The first step to Polia's problem solving is to understand the problem. So in this case, it's understanding what is this asking. Another way of saying this might not be such a pretty picture, but if you could imagine these bats, head to tail, head to tail, head to tail, one after the other, could you picture how long that string of bats would run? We'd have 31 inches plus 32 plus 32 plus 32 plus 32 4 times, plus 33 3 times, plus 34 5 times. So if we do this multiplication and then add, we could get the total length of all the bats, or in other words, if the bats were placed head to tail in a long straight line, how long would that nasty line run? The mean of the bat lengths. To get the mean, we're looking for x bar. I'm going to need to have the total length all together and divide by the number of bats. So the total length altogether is what we found in this square. So we'd put that here as the total summation of all the x's. And then how many bats are there? We've already determined that there were 13 bats total, so we would divide by 13. And that's going to give us the mean of the bat length. The median of the bat length, if we listed all of the numbers, now it's not done like this yet, but if we listed them, 1, 2, 3, 4, 33s. You know, I'm seeing that I could simplify this by, I know they're all 30s, so I'm just going to list them as 1. So 31, 32, 32, 32, 32, 33, 33, 33, 34, 34, 34, 34, 34. So we've got all 13 bats accounted for. Let me pull this one in a little closer. And then I could find the median by seeing what's immediately in the middle. This also shows me the mode. So there were more 4s, so more 34-inch bats than anything else. And then the range, if you see here in the page, the top right, the range is telling us the distance between the high and the low. The shortest bat was 31 inches, the longest bat was 34, so the difference is going to give us the range. By the way, the mid-range is that number immediately in the middle, so that's going to be the 32.5. Even though this one doesn't ask us for the mid-range, it would be helpful to know how to calculate that. This next graph tells us about the weights of turkeys, and you complete this number 3 in the same way that we completed number 2 with the bats. I've started by just writing out for myself the 4, 9, 7, 4, 1, 2, reading the bars. I just simply wrote down how many turkeys or how many turkeys were at each weight. So I can see that there were 4 11-pound turkeys, 9 12-pound turkeys, and so on. And the total number of turkeys sold is going to be the sum of this list. So 4 plus 9 plus 7 plus 4 plus 1 plus 2. If I added those all up, I'd get the total. The next question asks the total weight of all the turkeys sold. So I'm going to add each turkey's weight times the number of turkeys that weighed that amount. So we had 4 11-pound turkeys. So altogether, those 4 turkeys weighed 44 pounds. We have 9 12-pound turkeys. So I could multiply 9 times 12 to see how many pounds that adds up to. We have 7 13-pound turkeys, 4 14-pound turkeys, 1 15-pound turkey, and 2 big 16-pound turkeys. If I continue multiplying, each weight by the number of turkeys that weighed that much and add the products, I would get the total weight. I'm going to need that total weight to find the mean, because I'll take the total weight and divide by the total number of turkeys, and that'll give us the mean. I could find the mode easily by seeing that there's more 12-pound turkeys than any other. And then for the range, I'm looking for how far of a distance is it between 11 and 16. From 11 to 16, if I subtract 11 from 16, I get 5. So I can see that the range is 5. I do want to point out, just a side note for the graphs, you should be able to look at this graph and determine, is it a bar graph or is it a histogram? I can tell that this one is a bar graph, because if it were a histogram, the bars would be touching. Also, the bars in a histogram could have a range, so I could have called this first class 11 and 12, and then it would have had a total of 9, a total of 13. And then the next class would be the 13 to 14 pound turkeys, and then the last class would have been the 3 tall, and it's the 15 to 16 pound turkeys. So if it were a histogram, it could have looked a little bit different. But that's just a side note, so as you continue through this chapter, through the study of statistics, you can apply that. This last page has some problems that require us to really better understand X bar, or the mean average. So I've set up some hints for you for this last part. I'm going to suggest that if you need more help with problem number 4, that you pause the video and see if you can't apply what's written for each of these problems to what you understand about a mean, about an X bar, and see if you're able to finish these 4 problems on your own. Just in the case you do need a little more explanation, let's look at example D. We've got for example D a mean score of 80 on the first 3 tests, and then a mean of 90 on the last 2 tests. So our total point accumulation is going to be 3 times 80 plus 2 times 90. If we divide that by the 5 tests, we'll get the X bar. For example A, we do it the same way, 4 times 100 plus that 5th score of 120, divide by the total of 5 games, and that'll give us the X bar, the mean. Letter X, Oshkosh had scores of 76 and 77 so far, and what does he need on his 3rd test to get an average of 80? So if we add 76 and 77 and we let X be that missing score, we could see that his running total needs to be 240, because 80 times 3 would be 240. If we subtract his 76, subtract his 77, we're going to be left with the score for that last test. And finally, the Flicks Theater sold a mean of 472 tickets per day. So the key here is that we know that N is 7. We could multiply 472, the mean, the X bar, times the number of days to be able to find the total summation of each day, the sum of each day's tickets added up for all 7 days. Well, I hope that that helps you with these activities. If you do have further questions or need assistance, please feel free to contact me. I'm happy to help you further with any of these problems or similar problems.